Hello,
Sure.
this is the Surviving Healthcare Podcast, and I've got my friend George here who is going to tell us about EMF, and he's going to tell you about his qualifications, which are quite extensive. He's an electrical engineer kind of person, as I understand it. But let me just kind of go over the super basics so we're all on the same page. Um, Everybody's worried about EMF, and there is extensive evidence about it causing cancer and especially localized cancer in the areas of the brain which are impacted by cell phones and uh, cancer in rats and women who carry them in their bra get breast cancer, and there's a lot of other data too. There's small print in all the cell disclaimers that you should not hold them near your head, which most people don't know. And the original testing was done with this mannequin that weighed over 200 pounds, and they didn't document any heating. And so the heating phenomenon around the under the cell phone was the only thing they thought was important, and that's been the narrative that has been carried through. But we now have thousands and thousands of studies that implicate the cell phones and all kinds of things: arthritis, anxiety, bad dental hygiene. I mean, it just goes on and on and on. How credible it is, George is going to um, uh, clue us in. Even cardiac arrhythmias and blood pressure problems. So, George, without further ado, tell us about your background and qualifications, and then launch.
Thanks. I studied a general engineering program in university and with a specialization in some electrical engineering courses and digital communications. So I have a fair bit of theoretical knowledge of how those things work. But I've spent a lot of most of my life, exposed to some sort of alternative medicine and different hidden dangers. And perhaps it came from my parents, but they were kind of attuned to the wireless potential problems early on. So I've paid a lot of attention to that. As a result of that, I've read a lot of studies. I've read a lot of different things about how to measure them. And I have a lot of testing equipment of my own that I purchased because, frankly, it's very difficult to figure out what exactly is going on in your area without actually testing it, because it's invisible. None of your senses can pick up those electromagnetic fields or the electric fields. So you need equipment to be able to sense it. So I've done a fair bit of my own experimentation, and then as a result, over many years, I've gained a fair bit of knowledge in this topic.
So take us through what you know. I mean, I can ask you questions, but you have some things you want to bring up.
Yeah, so I think what's there's no question in my mind as you introed this that there's a heating effect, and that's very straightforward. Your cell phones, one form of very common Wi-Fi, they all share the same frequency domain as a microwave oven, literally the same frequency. And that frequency is designed to excite water molecules in food and heat it up. So that's a known phenomenon. And all of the documentation, as you noted, in studies around it have focused on that. But there are other phenomena that are associated with it that have been measured in laboratory experiments, giving plausibility to other biological effects. And I would say by now, I think there's a lot of, I hesitate to use the word anecdotal, but there's a lot of people who are very sensitive to it. And my father included in that mix. And so there's clearly something going on to some subset of people for sure. And my assumption is that if it's bad for, really bad for some people, it's probably not good for anybody. And then, certain people are more susceptible either because they're weak or they've got specific susceptibilities. But generally what I've tried to do is just minimize my exposure, but you kind of have to understand how it works and how many different exposures you can get, because these things are not all the same.
So there's 4 types. The Wi-Fi, the radio frequency, smart meters, and then that's one. Second is magnetic fields. Third is electrical fields, and then there's the dirty electricity. So maybe that's too much detail.
Well, so let's kind of go into that, and I'll break it down slightly differently. So there's 2 types of fields, and this is actually, if you go way back to high school, probably everybody covered this at one point, the very basics of it. When you run power through current, and I don't know if you remember the right-hand rule, right? So you took a wire, and if the electricity was running this way, you would put your hand up, and then your fingers would point to the magnetic field that would form around the wire when the current's moving this way. So that's the very basics of all of these things. There are several different characteristics about it. There's also an electrical field and a magnetic field. The thing about electrical fields is they generally don't penetrate very well. So if they're inside if the wires are inside a conduit, or they're inside behind a wall, even your skin will block a lot of that field. So it doesn't penetrate very far. And they also tend to drop off very quickly with distance. So unless you're right beside something, and some people talk about, they're using their hair dryer and other things, and they measure it, and there's a big electric field. You hold it a little bit away and it drops off very quickly. Same with your, a little clock radio or something like that. You probably will measure one if you go right up to it, but as long as you're not sleeping right beside it, it's probably dropped off by the time you get there.
So address these meters. That I got my Ghostbuster meter.
So your meters, you have to look at each specific meter. Now yours there, I believe, covers both electric fields and electromagnetic fields. So it'll cover both. And then the other aspect of this is that the frequency of the fields makes a big difference. Now, just to frequency, the higher the frequency, so basics for communication. Over time, the frequencies of all of these devices have gone up because the higher the frequency, the more data they can carry in terms of digital communications. But the downside of that is that the higher the frequency, the less penetrating power it has to go through objects, solid objects. So a lower frequency signal will actually penetrate very readily through a lot of things, but the higher frequency signal, which can carry more data, penetrates less. So those are 2 basic things. The other characteristics of these signals are there's like very low frequency things. So you can get off your power line. So the power lines in North America are operating at 60 hertz, which is basically 60 times a second. It's flipping back and forth. And so anything from a power line is going to let off a 60 hertz electromagnetic field. Those penetrate quite far. It's very, very difficult to block them. You need some expensive metals, and you kind of have to totally surround the wire. Now, one of the good things about modern wiring in houses is that there's always 2 wires going to something, and the current running this way is exactly the same as the current running that way if it's wired properly, in which case the majority of the field cancels out because they're opposing. And so when you get most houses, if you're not right up to the wire, generally the magnetic field will drop off very quickly. Now,
like within a couple of feet.
Well, and so I guess we can quickly talk about that. The electric and magnetic fields both decline at the inverse square of the distance. So if you're 1 foot away, it drops off by X. If you're 2 feet away, it drops off by 4X. If you're 3 feet away, it drops off by 6X. So it's 9X.
9X.
And then, or the cube of the difference. That's the other one. So they drop off very quickly. So putting any distance between a magnetic field and yourself is going to cause it to drop off a lot. So, for instance, I always used to, even from the very beginning when I was finally forced to have a cell phone, I used to, and I'd seen I'd read about all the cancer in the brain from those, those original cell phones, big, and they had a lot of power. They were blasting out a lot of signal. We'll talk about power in a second, but the power that a device has is going to be directly correlated to the strength of the signal. One of the clues or good rule of thumb you can use is that if a device has a small battery and it lasts a long time, it's probably not letting off a very strong signal. Your cell phone, it's got a big battery in it and it lasts maximum a day because both the screen and the cell communication is quite powerful because it's trying to send the signal potentially a couple kilometers away. Or miles away, kilometers, miles. And so again, I used to carry the cell phone, but whenever I used to carry it in a holster, so it's at least a couple centimeters off of my skin. So
did you have a Faraday material on the back of your holster?
I did not. Now, I've tested out some of those materials. I think I could actually, aluminum foil would probably do it better. Some of those materials don't work when you're putting them right up close to the source. They don't work as well. They don't block, but they certainly reduce. So those materials you see, they call it attenuation. They decrease the strength of the signal. That they don't stop it generally. If you put like a real cage around it, it'll stop if most or if not all of the signal. But you could probably put just foil. I mean, you'd want to test it. I would want to test all these things. There's a couple. I'll just talk about the devices and the antennas for a moment. But the cell phone, you can judge by the battery size. If you have a little, wireless transmitter, like those little air tags and things like that. What is the battery lasts a year and it's a tiny battery? Signal's not going to be very strong and it's not going to be very frequent, right? It's going to be sending a signal infrequently and it's not going to be that strong because otherwise the battery would run out. So that's just a good rule of thumb. Again, keep some distance. When I'm standing here, my cell phone's not on my body anymore. It's off on the desk, at least a foot away, however far away it is. But the signal has now dropped off substantially compared to when it's sitting right in my pocket or right against my body.
Did you Ethernet wire your computer and all that?
My whole house is wired. I don't use cordless phones. I do have a cell phone because it's very difficult to function in today's society without one. But I have, actually, you can even kind of see, there's my phone. It's wired. All the phones in the house down there.
That's great.
In the house are wired.
So you take this risk quite seriously because this is not it's a little bit of a trouble, even if you're an engineer.
It is it's work. Now I've had a cell phone for, good 1997, 98, probably when I first got it. So I've had it for many years. Basically the approach I'm taking is I'm sure it's got some negative effect. I can't quantify exactly how much for me. So I try to minimize as much as possible my exposure to it. The hardest ones to block are the power line signals at the low frequency again. So that's if your house is bad wiring. A lot of houses now, it depends where you live, but I live in a big, kind of a crowded city, a dense city. A lot of the houses are packed together and the power line comes up in the air and it hangs up and it goes to the top corner of the house. And often there's a bedroom there. And so the person's head is sleeping right where the electricity power line comes into the house. And if there's a multitude of house wiring, either issues or problems even from the utility that can create substantive magnetic fields. I had a meter very similar to yours that my wife and I have been using for years. When we were looking for rental places or when we went to buy a place, I would test out the house and figure out, or the street. Sometimes I went to streets where the whole street was bathed because the power line on that street was old and there were issues with it and it was generating a large field. I wouldn't choose to live near a really large high power lines. That's been a long kind of, there's certainly some studies that have shown a small effect, but any industry funded, as we know, anybody listening to your show, any industry funded study is going to be dubious at best. And they're simply not interested in studying these things because it's a very large lucrative industry, and it's almost, everybody has phones and communication and power. We all need that to survive. So there's not a lot of desire to find problems.
So until recently, you would have said that the power lines were exposing you to more electrical dirt than cell phones or anything else. But now maybe it's changed with the 5G.
Yeah, there's no question now that the density of the high frequency electromagnetic fields coming from all the electronic devices, all the wireless devices, right? So Bluetooth, cell phones, Wi-Fi, tablets, anything that's doing a wireless communication, that the density of those fields, the amount of those fields has increased substantively. So if I go downtown to the city I'm in, it's just absolutely, no matter where you go, there's so many signals there. You're getting bombarded with a lot of signals. Even in my neighborhood, like I can pick up Wi-Fi from 10, 12 neighbors. Now there's a few more things. So I just want to, let me cover off the power line thing. So a very simple meter though will detect that. So we used to walk into houses, rentals, and test it out, and we'd say, okay, this field is coming from the street, so this whole street's no good. Or this house has a problem where the power comes in, but it's pretty good everywhere else. So if it's just a stairwell there, who cares, because you don't spend much time there. My own house, when we renovated, I did some special things to make sure I wasn't getting any problems from the outside. I did eliminate some fields, and I have a very quiet, low power line readings in my house here. So that's just power line. Now there's the dirty.
Let me just ask about a quick question about that. Do the plugins like the Stetzer, STETZER filters or plugins, you're supposed to plug the little magic things into your outlets, 2 or 3 of them in a room when you're sleeping, or maybe they cost $20 a piece, or sometimes more if you pay too much. Or what about the whole house filters for the power lines?
So let's talk. There's 2 different things. There's just straight power line frequency stuff, and then there's dirty electricity, which are 2 different things. So what you're talking about, those filters, they're trying to address what people call dirty electricity. And I did, since the last time we briefly chatted, I did a little more. I talked to some experts who know a little bit more and who do this testing for a living. And I got some more information. So I'll cover that in a second. But just straight power line stuff. You simply need good wiring, and you don't want to be near any big electrical equipment. And a lot of people aren't aware that their sleeping space is, either right near that power line that's coming in from the house. I know there was a lady on the street. Her daughter went to school with my daughter, and she was sick all the time. And I went to their house, and there was a huge power line field in the bedroom where that daughter was sleeping.
Did you bring in your Ghostbuster and show her?
Yeah, I had the meter with me. And I have a bunch of meters. I brought my cheapest, simplest one because it's just a little needle that goes back and forth, and it's that for that simple thing. The thing about a power line meter is it's always going to have the EMF as long as power is running. So if you've got stuff turned on in your house, it's going to be there. The trouble with digital communications and wireless stuff is they're not always communicating. So if you go measure them, you might not measure anything, and then 15 minutes later, all of a sudden it might wake up and start talking.
And this Stetson presumably will measure the power line problem.
So the Stetzer meter,
or Cornet, sorry.
The Cornet does measure, the one you have does measure it. You have to switch it to Gauss mode.
Okay.
To get that to work. I looked that up, but yours does measure that, and I would take advantage of that.
It's about $180. And of course, I go to YouTube for everything. I learned everything I knew or know on YouTube, and the fellow there who was talking about it, who I don't think had a connection with the company, said it was the best inexpensive ones. You've got the fancy ones.
So I have one like that. The cheap one I was talking about that I was using for a long time, just mainly for power lines, just a simple tri-field meter, which is probably a bit cheaper than that Cornet, but it won't cover any of the wireless frequencies or things like that. So that yours is much better because it covers all the wireless and it does the power line.
It's $180.
Yeah, that's a good one. So with respect to the power line, you basically just want to move away from those things and then fix any electrical problems. That can be challenging. I would strongly recommend you talk to some experts if you're noticing you have high power line readings in your house. You'll need to talk to, there's some online I actually engaged with in California. We can, I can send you the link. Actually, I think I did send you the link.
I'm just going to shut off the power and rewire it myself.
Well, and
No,
I did all the work myself.
I know you're a little different animal.
Yeah. Well, I was changing outlets when I was very young in the house. I got shocked a few times. It happens, but yeah, you got to be careful with that stuff. So I think that covers off the important thing about the power line frequencies. And again, they're very hard to shield. So you basically have to eliminate the source of the field. And if your whole block is full, there's not much you can do other than move away. Mind you, I'll just say I have a cottage near some high power lines, but I spend very little time there, so that's why I kind of go with it. And I do measure the field to my bedroom. It drops off just enough just before it gets to my bedroom. Let's see. And my philosophy has always been keep the bedroom as quiet as possible from all the signals. So I've never ever had a cell phone in my bedroom. I've never had any wireless devices in my bedroom. A lot of people like their computer, their tablet. My Wi-Fi barely even covers the bedroom. It doesn't even reach that far. So let's talk about dirty electricity. So that's the Stetzer unit. So there's this one's tricky because when you plug in certain devices, so let's pretend this is a 60 hertz curve. If everybody knows, this is the 60 hertz power line coming off when you plug something into the wall. It's going up and down like this 60 times a second. When you get some electronic devices plugged in, they can introduce higher frequencies. So on that power thing, they start doing this. It goes up and then it goes down. But they are operating at a higher frequency and they're generating fields potentially that run all through the electrical system of your house. Now, I've read a lot, and this one's super hard to quantify. And I have a Stetzer meter and I have another brand meter that measures something similar, just different units, but it's measuring how much of this high frequency signals you have, and they're not super high frequencies, they're not in the same range, let's say, as your Wi-Fi, they're much lower than that. And how much fields that's generating. I talked to the experts, I was looking it up, and they, I just could not find a lot of hard studies on the measurement of that device. Like, unfortunately, they don't have any meters that you can measure the magnetic field effect from the dirty electricity. So there's an assumption that the dirty electricity running in your walls is giving off some EMFs and that it's negatively affecting you. There are one or two, three studies that I found that talked about potential harms. They did document some harms, but they were like one or two or three studies, low sample sizes, all sorts of other, I wouldn't call it strong evidence, but it's evidence of a potential problem. So, I did, after we chatted the last time, I went through my house and measured it with my meter because I hadn't looked at it in 6-7 years. And I found, interestingly enough, so most in North America and United States, Canada, I don't know about Mexico, but there's two legs of the electricity. There's one, they're both 60 hertz. One goes like this and one's the inverse. It goes like this. So things like your stove use both of them, and then you get 240 volts. They're double the voltage, and then the regular outlet is just one side or the other, 120 volts. And one of my legs in the house was actually quite noisy, and one was, mediocre. And it was consistent throughout the house. So I was like, okay, where? And I was trying to so I started switching things off until it disappeared. And sure enough, it was my computer rack in the basement. with all my networking equipment, wired networking equipment, that was giving off, causing on the one, whichever one it was plugged into was sending that stuff through the house. I had one Stetzer filter, which I bought many, many years ago just to play around with. I didn't use it at the time because it gave off a tiny little high-pitched hum that was irritating. So I took it out of the bedroom and then I never used it. It was sitting in my drawer. So after we talked, I went and played around with it. It does reduce the field. I put it near my computer equipment, which is noisy.
So
anyway.
this thing is a 2-inch by 2-inch thing with a couple of plug-ins, and you just stick it in your wall socket, and it supposedly helps.
As close to the source. And what it does is smooths out the high frequency, it filters out the high frequency signals on the 60 hertz wire. Now, if you measure it, and this was interesting because I was reading online and some people saying it draws power. If you measure it with a meter, like a wattage meter, it will seem to draw power, but it's a power factor thing. So it's a phase type thing where it's not actually costing you money. So it doesn't increase your electrical charge, but technically it has a wattage associated with it. So I plugged one in on that bad leg. The rest of the noise was coming from the street, it would appear, in my case, because it was constant baseline, didn't matter what I switched on or off in the house. It was the same. So it was coming from other houses or whatever in through the system. Yeah, I honestly can't quantify the risk from the dirty electricity. And you have to buy these things to put them in your house to quiet it down. I can't say whether it's worth it or not. I don't have, mine's not very high, so I'm pretty happy with that. I'm not going to worry myself. Now, a lot of people, what they do who are sensitive, they will disconnect all the electricity in their room where they sleep, for instance, at night. Where they'll have, they'll get an electrician to wire a disconnect cutoff, and it will shut off the power. It'll physically disconnect the wires that are in your room, and therefore you won't get any dirty signals, nor will you get any power line signals there.
What about just going to your breaker box and trying to find the area of your house and shutting that off?
You could absolutely do that too. That would work as well, for sure. If you shut off the breaker, there's no connection to that part of wherever that line runs, there's no electricity running on it.
So you do your idiot check, you walk around to the front, you shut off the darn a modem and all that equipment, and then you go out to the back and shut off your electricity to your room, and then you go in and hopefully have a good night's sleep.
Yeah, you could do that. And that's literally basically what some people do. It is basically a breaker. It's just sometimes they have it on a timer or another switch, and they don't have to go to the basement and whatever. But that's in effect what it is doing. It's a contactor, it's called, and just shut off the power. So that's what people do, either to address both power line and potentially dirty electricity. I focus more on the power line stuff than the dirty electricity, because I've not seen enough quantification of the risk. And if your power line signal's quiet, I believe that your dirty electricity will also be quiet, because it should also be canceling out. The folks I was talking to saying they're hoping someone's actually to come up with a meter where you can actually measure the in the air electromagnetic effects from the dirty electricity, but there isn't one right now on the market that they were aware of.
And the power line thing, what is the name of the setting on my Magic Cornet?
So on the Cornet, it's called Gauss mode, and it will give you a measurement in something like milligauss. It probably has two alternative measurements. I forget what the other one is, and you want it fairly low. I think it's like 3 milligauss or lower is like a really good number. As it gets higher, then you want to figure out where it is. Now, actually, this is good that you brought this up. Those meters are omnidirectional, so they're picking up the cumulative signal from all directions. So they're not gonna. So if you're standing somewhere and the signal's high, you're really not going to know where it's coming from that. So I have one meter that I have where it's directional. So as I rotate it around, the signal will go up and down as it aligns with the magnetic field or not. And from that, you can kind of tell the direction that it's coming from. But that's actually really tricky to do. It's nicer to have the Omni ones like you do. And you just walk towards different directions and see when it goes up. You're probably getting closer. You are getting closer to the source of a field. But remember, it's cumulative. So it could be coming from multiple directions at the same time, and you're measuring all of it.
So of course the thing everybody's paranoid about is the 5G. And as I understand it, and I've just read this stuff this morning, those are the higher frequency ones, and these jackals are considering putting these little cell towers every 300 feet throughout an urban area, which sounds like they're really coming to get us. I mean, it just intuitively sounds horrible.
Now, and I'm not going to talk to motives. I'm not going to go into that. But I will say the reason they want to do that is because the higher frequency doesn't penetrate as far.
Right.
So they need to put them closer to where you want to use them. So they'll get through the walls of your house, for instance, and then you can use the 5G signal on your phone. And the reason they want to go higher frequencies is because they can move that much more data. Everybody wants to watch TV and YouTube and everything on their phones. They got to pump a lot of data across that. And so that's how technologically they're doing it. The problem is they're simply not testing, and they're not interested in finding any problems if there are any. So I'm always highly skeptical of these things. So I would assume there's a problem until proven otherwise. And you simply want to minimize your exposure.
When there's a loud cover up, you can assume that there's something they're covering up. Yeah. So back to the dirty electricity and maybe the smart meters and all that. I read also about a commercial box. If you're stuck with a 5G meter, you can buy a magic box and put on your meter and fix that one. I guess it's a Faraday box. Is that true?
So let's talk about the smart meter. The smart meter.
That's the thing. You walk out back, and if it has digital display on it, it's a smart meter. If it has a little thing that's rotating very, very slowly, then the meter guy has got to come up and read it, right, at intervals. Is that the way it works? And that one's not as problematic. So sorry to interject.
So yeah, and it's a good point. Now, I always do measure the electric field there, right? Because that's where the main power is coming in the house. It'll be high right near that meter. What you want is that it drops off really quickly as you walk away. That's important. If it's not dropping off, then there's probably an imbalance in the power going in and out of your house. Could be going out some of your plumbing, could be coming in some of your plumbing. There's all sorts of weird things that you probably should engage an expert to figure out what's going on, or read a book about it that you would understand.
Are older houses more vulnerable?
Yes. Now, yes. And so this is an interesting thing. When we were walking around with these power meters, I could find a house. So there's different ages of wiring that went through North America, right? So there's an old type of wiring called knob and tube that you might have heard of.
No, I never heard of that.
Well, basically, it was literally knobs, a big knob, and a tube where the electrical wire would run through a ceramic tube when it was going through, your joists and things like that, and it would keep the heat away from the wood. And the thing is, it wasn't two wires, so it would do a loop. So the electricity would run all the way around your room, and then it would come back on the other side. Well, if you remember from high school physics, how do you create an electromagnet? You do a loop. That's exactly what you do. And so you create electromagnet. So any house with knob and tube, I could instantly see it on my meter. It would just light up, and you turn on a light and the thing would go boop, turn off the light, it goes boop. And I'm like, this has knob and tube wiring. I don't have to open the walls, anything. I can detect it right away with a simple meter. So yes, houses that have knob and tube wiring are definitely going to have high power line fields in them, especially as soon as you turn on things or plug them on. If your house is older, it's probably more susceptible to wiring problems, but not guaranteed. I mean, it's how well the electrician, screwed things in, if there's, and then whether or not, let's say you've got some leakage out the ground through your plumbing. So a lot of things are grounded. If you've got a bad you could have a bad device that you've got plugged in and it's leaking to ground, in which case now you're creating a big loop of electricity and that's going to generate a field. I had a small field in my house after the renovation, and I tracked, and I was like, where is this coming from? I was in my basement, and I tracked it. It tracked all the way along my refrigerating, the air conditioning line that was going outside to the air conditioning unit. And I found out that some of the older, and I do have an older air conditioning unit, and some of them, they start to leak a little bit of electricity from the compressor into the ground wire or into the casing. And that was then going back up to my furnace through the copper tube, and then from my furnace into the ground. And so it was creating a little loop, and it was just a tiny bit of electricity, so the field wasn't that big. And all I had to do was insulate that copper thing so it couldn't get to the furnace, and then that solved that problem. But yeah, so older wiring, you can have weird problems, and you'll detect it with that power line meter, or the power line, yeah.
You know, the more I listen to you, the more I think maybe a consultant might be reasonable. How much do these people charge? Hang on, I've got it.
I honestly don't.
Can you come back later? Can you come back later? Huh? Come back in 20 minutes.
Anyway, sorry.
Yeah, no problem. I honestly don't know. I can't remember. Like I engaged them about it 10 years ago, the folks in California who were quite good. I would highly recommend them. And he did just basically a phone consultation with me. So I only paid for an hour or two. I'm sure it was under $200. But I was paying, but then I know what I'm doing. So I could converse with them very quickly. And I was explaining the problems. He would tell me to go measure things. I would measure them, email them back. And then he gave me some help on how to track things down or how to solve them.
Yeah.
The challenge is you probably, people who don't know anything about electricity might have to do a little bit more work, and so it might cost more money. It's probably going to be a similar charge to what an electrician would charge on a per hourly basis.
And a routine placement of some sort of electrical device at where the electricity comes into the house, that can help, but it's not always indicated.
So so back to the meter thing. So there's the power line signal, but the smart meter, what it's doing is it's sending a digital signal back to the utility saying, this is how much electricity you're using. That's basically what it's doing. Now, not all the smart meters are the same. Some of them collect the information, then broadcast it once every 45 minutes. Some of them blast it out all the time. The thing about the power meters that's problematic is they're designed so that the power utility company didn't have to put receivers everywhere. So what they're designed to do is blast out at full strength, because they got full power, right? They don't have to worry about a battery running out. They have full power. They blast out a signal, and then they relay the signal across all the houses. So it can go quite far. I mean, it's pretty ingenious from its engineering solution perspective, because they don't have to put a station everywhere to read it, because it just broadcasts across the whole neighborhood. But it's blasting a ton of power. And some of them, already 10 years ago, I remember when they were getting rolled out here, some of the fellows at one of the stores I buy a lot of the equipment from had done a measurement. And it's a timed measurement, because when you're dealing with high frequency digital devices, they don't broadcast all the time. They broadcast in bursts, and then they'll stop. And so you kind of have to set up recording equipment, measure it, and then measure it over an hour and see what it does. And some of the smart meters, like I said, were broadcasting once every 45 minutes. Some of them were broadcasting continuously, like once a minute. They were just blasting it out. So it depends on which ones you have, how they're set up. Now, that's a wireless frequency. So it's some higher frequency in the gigahertz range, probably, I would guess, 2.4 gigahertz or higher. And 2.4 gigahertz, by the way, is the magic one. That's what your microwave is using to heat your food. That's what your Bluetooth is using. That's what the most common older Wi-Fi is using, and your cell phones also might be using it. So they all use that frequency. And so you can shield that frequency. So you can put probably a cage, even you always have to measure these things, because you never know if it's working or not. But if you surround it with a screen, like a metal screen, like an aluminum screen, it might shield most or all of the signal. I know at my cottage, I had metal screening on my porch. It blocks the cell phone signals, or it certainly reduces them a huge amount. You don't get a signal, you walk outside, you get a signal, right? Same with the metal roof will block it. Something else that blocks it quite readily is real stucco, not the fake stuff, but the real stucco that they apply. They put, I don't know if you've ever seen it, but it's a metal lath that goes on the wall, and then they put the stucco cement on top
So
of
it's
it.
the lattice work, the metal lattice work that
That
blocks
metal
it,
lattice
not
work.
the.
I
Yeah.
looked at a house and I went inside and my cell phone didn't work, only worked near the windows because it was blocking all the signals.
What
Now,
about masonry?
it'll block signals, but not like that, not like the metal.
Not like the metal.
No, but
So-
it's screen side, right? It'll block a fair bit of that signal. So
I don't want to
forget
forget.
block the signal on your power line meter, but that's, again, it's a high frequency signal there. It's not the power line that you're looking at. It's the high frequency thing. And my, I'll say the water utility, they put a wireless one for that as well, so they don't have to come read the water meter. But that one has a 10-year battery.
So that's nothing.
I'm assuming it can't be anything because otherwise the battery would run out. It's not going to have a lot of power. It's not going to broadcast very often. Probably broadcast once a day for like a second and then it's done. That's my guess.
I might be bouncing around here because I don't understand these categories very well, but how seriously do you regard those microwaves? Because they're only being used for very brief periods. I mean, I don't stand in front of it, but it seems like a stretch to get a convection oven.
Here's my, yeah, I don't stand near them I mean, you're only using it for a few minutes, so I'm generally not worried. My mother was a cook. My grandmother was a chef. My great grandmother was a chef. My great grandmother used to love them as a chef because they quickly heat up food, right? But my mother never liked the microwave at all. She said it changed food and made it unhealthy. So I grew up without a microwave and I kind of just adopted that attitude. I can't say scientifically that it does anything good or bad, but it does blast out a signal. There's no question. You can, I mean, I think you said you measured it and it was super high.
Oh yeah, it was high, but just for a very short period.
It is. While it's on, it'll be high. Think about how high the signal is inside. It's actually got pretty good shielding. So that's getting through the shielding and coming out. I just wouldn't stand near it. It's the same with an induction stove, right? An induction stove works off of magnetism. It's generating big, super strong magnetic field. So if you're close to that thing, I bet, I haven't actually measured one, but I'm 99% sure it's going to have a very high magnetic field, probably in the power line range.
Did you hardwire your TV?
I've hardwired every device I can hardwire is hardwired.
A lot of those latest TVs, you can't do it. And one of the recommendations Mercola had was to put it on a power strip and turn the darn thing off at night. When you make your idiot rounds at the end, you turn off your TV.
100%.
It's constantly active. You turn off your router or whatever it is. And then, maybe if you're really paranoid or smart, you turn off the power to your bedroom.
Yeah. So I turn off my Wi-Fi at night, the one near, so I have multiple broadcasters.
George, you just admitted that you had a Wi-Fi.
I do. If you have a tablet or you have kids who have the tablet, you've got to have the Wi-Fi or stuff doesn't work.
Yeah.
What I do.
We don't have a good cell signal. We need it for the cell.
Well, there's that too.
Yeah.
And, cell repeater is the same thing. Now, remember, there's a couple non-intuitive things that you have to think about. So if you have a weak cell signal, that's great because your exposure to the tower is small, right? The signal coming from the tower to you is not very big, but your phone now has to amp up the power to full power to talk back to it, right? So now this little thing, which is very close to you, is going full power. So generally, I don't actually know cumulatively, I haven't measured it, but I actually have more Wi-Fi points in my house, but they're all running on low power. If you run your own network, you control the power that's on them. So I run them all at low power and I just have lots of them throughout the house so that they're not blasting out a strong signal. And then I shut off the ones near my bedroom at night and I have to physically disconnect it. So some of these Wi-Fi routers, they let you program in a schedule. You still have to measure it. Mine, even if I turn it off at night where the Wi-Fi network disappears, that unit is still blasting out signal doing something. Don't know
It
what it is.
doesn't have a battery, does it? You
No,
use
no,
a
no,
power strip.
It's powered, it's powered in. Yeah, so mine's powered into the switch actually. So the power is coming over the internet switch. And so I through some fancy stuff, I disconnect the power at night, and that's the only way to do it. Disconnecting the power strip on your router is another way to do it. That's what most people have. They have this, their telco gave them this box, has a modem, and it has a router in it, and it has a Wi-Fi access point, and it's usually set to full power because it's trying to reach all the areas of your house, no matter how far away it is. And the other thing about those, I definitely would not sleep. I would not have that near me. Even if I'm working all day, I wouldn't have it on my desk. I would have it far, not as far away, but far enough away because it's blasting at full power. The other thing is sometimes you can switch off the Wi-Fi on those, but be careful. For example, my provider, it has 2 radios in it that I can that will give me Wi-Fi. So one at 5 gigahertz, one at 2.4. And I can switch those off, but it has a third one that's hidden. You can't see it, you can't control it, and it's designed to talk to the wireless TV boxes. But it's all, I don't have a wireless TV box, but it's always on. I can't turn it off. I have no access to that part of it. So it's constantly blasting stuff, and I'm trying to shield it. Basically, I stick it in some sort of box to try and reduce the signals coming off because I don't want those signals.
So I hate to introduce another complexity here, but what about the shielded Ethernet cables instead of just an ordinary one wrapped with plastic? Does that have any merit?
Well, they do have merit, but not for the purposes of reducing. You're not likely getting signal exposure from the Ethernet cable itself. I mean, again, what's interesting about the Ethernet cable is it's got twisted pairs in it. So the signal goes down one and comes back the other, and then they're twisted together so that they cancel out any signals. That also makes them less susceptible to external signals interfering with your communications. So the shielding actually is more to protect the outside interference going into the cable rather than vice versa.
Got it. And
it's expensive. Costs more. And wiring your house costs more. Like I have kilometers of wire. When we renovated the house, I pulled all wire everywhere. So everything that can be wired is wired.
What about this idea of grounding your MacBook? You can do it with a USB apparently, or you can switch the actual, you can switch the power cable or the power adapter somehow.
I honestly don't know. I've not encountered
with a third. Okay.
I don't know what that's trying to accomplish. I'm not going to guess because I don't know. Like grounding it of its own is another thing, right? People talk about walking in bare feet and grounding themselves, and I have not researched that a lot. I've heard help some people. I simply don't know if it's related to that or if it's related to trying to reduce the signal. I don't honestly see how grounding it would reduce the signal. Unless perhaps the casing itself is generating the signal, then grounding it would reduce that. Maybe. I don't think so though, because that thing's designed to broadcast the signal so that it can reach, the Wi-Fi device so it can talk to it. So I don't know how grounding.
So have we covered all those different forms of problems?
So the last thing I want to talk about is as we talk, I'm going to go back to 5G a little bit. It's gone into higher frequencies. Let's talk about the key aspects of these things. There's the power, so how strong the signal is. There's the frequency of the signal, and then there's another aspect of the signal, which is how often it broadcasts. And some of them like stutter and stop, and I've read that people believe that has an effect, a negative effect, but I've never been able to find out exactly how or why that is. I do know that the non-heating effect from the higher frequency radiation in the lab has been shown to affect the voltage controlled calcium signaling in the cells. Now, What effect that has on me as a human being over the long term, I have no idea, but I gotta believe if it's affecting the behavior of cells, it's probably going to cause some sort of problem at some point. How big a problem, I don't know. And that's kind of why I try and avoid these things. But those higher frequencies will have different biological effects because the frequency affects a lot of things. So there's a lot less testing. And you know, this morning I looked up online, tried to, you know, general health problems with studies on health problems with EMFs. And I found, you know, one of these summary studies where they looked at all the studies and they concluded it. And I looked at the thing, and a lot of the studies found no issues, but they were all very low frequencies. All the ones that did have issues were 2.4 gigahertz and up, which is the microwave,
5G,
the cell phone. And I was like, and then of course, they aggregated all of them together and said, well, they're in aggregate, the average, it looks like there's no effect. And I'm like, you're comparing apples to oranges at that point. So the frequency matters. And I have not seen a ton of study at all on the 5G frequencies and whether that's better or worse. I have not seen a measurement in my house. Let's say if I don't know if they've deployed it in my neighborhood, and here's the other thing. Not every telco has using the same frequencies. There's a range of frequencies that 5G can use. Some of them overlap with the old stuff. So it may or may not even be a different frequency. So again, it's very specific and circumstantial to where you are, what they've deployed, what's running there. I've seen some people, you know, online and people saying, oh, this 5G device is using, you know, whatever it was, 10 gigahertz or something, and it's like going to be in Wuhan and this and that. And I'm just like, and I looked up the device, and it's a dish, and it's designed for point to point. So it's like you have two buildings a mile apart, and you stick a dish on one and you stick a dish on the other, and it's talking between them and moving a lot of data back and forth. You're not getting a signal from that. The whole reason it's a dish is it's focusing all the signal in a very narrow band, and it's going over there. It's not blasting out like the cell phone tower is direct, like the directional, but it's a big arc. Your cell phone is going omnidirectional. Every direction it's broadcasting all around because it doesn't know where the tower is. So it goes in every direction. When you take all the power and distribute it across every direction, it's a lot less. If you focus it into a little beam like a laser, it's only going between it's going to widen a bit. So don't stand between those beams because you're going to get cooked. But they're usually high up. So don't tell me the dangers from that device, because that's not a problem. It's these things that we're carrying around, or the one that's broadcasting these things. That's what I would be worried about, because that other signal is never going to reach you. So people got to be really careful about what they think they're exposed to, or what they're saying, you know, online. And it's so different, and it's complex. Like I'm very sympathetic because it's very complicated, and there's a lot of nitty-gritty details.
So the impression I want to leave my reader or listeners with is of someone who's well-trained, very rational actor who has taken this quite seriously for at least a decade, maybe 15 or 20 years. And you've watched it all come around, and it is possible to mitigate this stuff. And maybe the ordinary mortals among us need to hire someone or talk to somebody on the phone and buy a Cornet electro smog meter. So I wanted to thank you. Is there anything else you want to bring up?
I think that's the main stuff. I think we covered a whole slew of it.
Yeah. No, this is excellent. And I want to tell you guys what Mercola said at the start when he started looking at it. He dismissed the whole thing, but he read practically every reference he could get his hands on, and he's just a voracious reader. And he's quite concerned about it all, to the point where I think he's had his house modified considerably to cut it down as much as possible. And his book called EMF asterisk EMF asterisk D, like EMF'd, right? That's the name of his book. And I thought that was excellent. I finished that this morning, and it has a lot of information about these products. And I will put references to my YouTube video, not mine, but the ones I referred to when I learned how to use that cornet meter. So that'll be helpful too. So George, I really appreciate your time and for volunteering to come on my show and help out. So thanks again.
Well, thank you. I enjoyed it.
I ended the meeting. So that's fine. You know, I
still-
really appreciate it.
I'll just say it still says it's recording, but anyways.
Okay, well, hang on. I've got to cut it off because I hate to stop recording. Hang on, I'll pause recording.